So number 1 on your worksheet says to use the similar cubes below to discover the ratio rule for the volume of similar figures. What we're going to notice is if we find the ratio of the sides, whether in this case it'd be the length, width, and height, or if you had a cone, you could use the radius. There's a relationship between the ratio of the sides and the ratio of the volumes of those similar figures. So let's first find the ratio of the sides. So if I look at, let's say, the length here, length, width, height are all the same for a cube, right? We have the length in the smaller solid is 4, and then in the larger solid is 8. So the ratio is 4 to 8. Now, we want to reduce this down, otherwise we're not going to discover what the pattern is. So 4 to 8 reduced down to lowest terms is 1 to 2. So this is the ratio of the sides, 1 to 2. Okay, now let's find the volume of each figure. So we have a smaller cube and we have a larger cube. And for both of them, the volume formula is length times width times height. So in the smaller cube, 4 times 4 times 4, we get 64. Okay, so now let's find the volume of the larger cube. Now once we discover this rule, we'll be able to use it as we go through these problems, and it won't be as long solving them. Okay, so in the larger cube, we have 8 times 8 times 8, and we get 512. Okay, so if we take the volume of the small to large, we would have 64 to 512. But those numbers also can be reduced down. So if you put in the calculator, if you type in 64 divided by 512, then you hit the math button and select fraction, it will reduce that down for you, and you'll get 1 to 8. So let's take a look at this. The ratio of the sides was 1 to 2. And the ratio of the volumes is 1 to 8. What's the relationship between those? What can we do to, what operation, or what can we do to the ratio of the sides, and we'll get the ratio of the volumes? Anybody know? Hopefully somebody does. Well, if you cube the ratio of the sides, you'll get the ratio of the volume. So 1 to the third power, 1 times 1 times 1 gives us 1. And then 2 to the third power, 2 times 2 times 2 gives us 8. So if you remember the video that Mr. Salazzo made, the rule for the ratio of the areas of two similar figures, it was you square the ratio of the sides. In this case, volume, you cube the ratio of the sides. Okay, so up at the top of your sheet it says, the volume ratio for two similar solids is equal to the ratio of the sides cubed. So this is the rule we're going to use as we go through the rest of the problems on the front of this worksheet. So number 2 says to write the ratio that compares the volumes of the similar figures. So instead of going through and actually finding the volume of both of the rectangular prisms and doing length times width times height, getting the ratio, reducing that down, we can just use the rule that we discovered before. So we can get the ratio of the sides, right? And if we just cube it, we'll have the ratio of the volumes. So you can look at either the length, width, or height. Doesn't matter which one. I'm going to take the width because if I take 1 to 5, it's already reduced down. If you happen to do, let's say, the height, 2 to 10, well, then you want to reduce that height down to 1 to 5. So this will just make it a little bit shorter for us. Okay, so to get the ratio of the volumes, you just cube the ratio of the sides. So I'm going to cube the 1, cube the 5. 1 to the third power is 1. 5 to the third power, just hit the caret button in the calculator, is 125. So the ratio of the volumes is 1 to 125. Let's try a word problem. Number 3. The ratio of the sides of two similar solids is 4 to 9. Now, if you were going to draw a diagram, we actually don't know what solids it is. It's not specific enough. You know, is it a cube or a triangular prism, a pyramid? We don't know, but that's okay because there is enough information here to solve this problem. If the ratio of the smaller solid is 1,536 cubic meters, what is the volume of the larger solid? Well, remember the rule we discovered before. The ratio of the volumes is equal to the ratio of the side lengths when you cube it. So what we're going to do is take the ratio of the sides, we'll just do small over large, and we're going to cube that ratio. So 4 cubed is 64, and 9 cubed is 729. Now we're going to set up a proportion. So we're going to take that cubed ratio of the sides, And we're going to set it equal to the volume of each solid. So we have the smaller solid, which we're putting the small on top. The smaller solid has a volume of 1,536, and we don't know the volume of the larger solid, so we'll call that x. At this point, you just want to cross multiply. So we have 64x, and let me just type it in here. When you cross multiply on the other side, you have 1,119,744. Just divide by 64, both sides. Type that in the calculator, and we get x to be 17,496. And this problem said that the volume was in cubic meters. So when you practice 4 and 5, it's very similar to this question. So just continue on with the worksheet.